Okay, I have some problems here to do um, with 6.7. Before I start on 6.7, I'd like to explain two concepts. And one concept is the distance formula. Distance equals rate times time, or speed times time. Distance equals rate times time. That is a very important um, formula for you to know. Distance equals rate times, that's a star, time. I'm going to put in quotation marks speed uh, because, well, we're just gonna say speed times time or rate times time. That's one concept I want you to write down in your notes. The other concept is the work. I don't want to say theory, but work in respect to time. I want you to think about this little scenario I'm fixing to give you. If it takes me 4 hours to mow the lawn, to cut grass, alright, what's the hourly rate? Well, you have to, each time you get one of these problems and it tells you so many hours to cut grass, that means that you have to set it up, and this is the way they all set up. You have to figure out rate times the time. Okay, time. Now, we know we can cut the whole yard in 1 hour, in 4 hours. But what is my rate times the time? We know it's 4 hours to cut the grass. But what's that rate? Well, we know that we can cut 1/4 in 1 hour. Because 1/4 times 1 is 1/4. What's 1/4 times 4? That's equal to the whole yard being cut. So this is where I get this in relation to rate times time. So when you set up a work problem, just change that 1 to a time, you're going to use this to give you this. So whenever you're dealing with a work problem, just remember, if Jane takes 8 hours to cut the grass or mow the lawn, then it would be 1/8 T. And if Jerry takes 3 hours to hang out the laundry, then that would be 1/3 T. So 1/8 T and 1/3 T. And these you need to know going into section 6.7. Okay? So let's start with one. One I have here, it says if Sandy can decorate a cake, if Sandy can decorate a cake in 5 hours, and Eric can decorate a cake, the same cake, in 4 hours, what is their hourly rate working together? hourly rate, hourly rate working together. Now, the whole concept of working together should tell you that it's going to be less than 4 hours, because the slowest or the fastest one is 4 hours. So if they work together, it can't be more than 4 hours if one of them can do it in 4 hours. It's a little bit of common sense there. If they was to do it together, but they want to know the hourly rate. So that means we're probably going to have to get a common denominator, and that will be if Sandy's formula comes out to be 1/5 T, and Eric's comes out to be 1/4 T, then multiply these two together. And that will give you, that will give you your answer. Now, remember, to get the common denominator, you do the little trick I showed you. Now, you don't have to. In this case, you have prime numbers. And if you have prime numbers, or the biggest one is a multiple of, the biggest one is a product of, or the smallest is a multiple of, then you can just use the biggest one. So you find the denominator how you want to, and solve the problem. Okay? So you got 1/5 and 1/4. So what do? You add them together? Yeah, that's what we do. We add them together. So the common denominator is 20. So let's just go ahead and say 1/5 plus 1/4, and that'll be 20 and 20. And 5 will go into 20 4 times. 4 times 1 is 4. 4 will go into 20 5 times. 5 times 1 is 5. And your answer is 9/20. So that's their hourly rate of decorating the cake. Okay? Now, that's kind of a leading up to question to get you ready for the actual problems you're going to work. I've got one right here. Jack can mow the lawn. What's the difference between mowing the lawn and cutting the grass? Jack can cut the grass in 4 hours. And Marilyn, I don't even know how to spell Marilyn. Marilyn can cut the same grass, or the same yard, mow the same yard in 4 hours. 5 hours. How long will it take them to do the same yard if they did it together? Well, the lowest is 4. So it's going to be less than 4. You know that Jack can do it in 1/4 time, plus Marilyn can do it in 1/5 time, and that's going to be equal to 1. Now, most of your problems are going to be equal to 1 until you multiply through by the denominator. And the common denominator here is 20. And I'm going to multiply through by 20. Put in a baby step. And that'll give you 4 will go into 4 one time, 4 will go into 25 times, so that leaves 5t. Five will go into 5 one time, 5 will go into 4 24 times, that leaves 40. And 20 divided by 5, oops, I'm sorry, 1. That's supposed to be 1. I just made up something. Heck, oh. What's wrong with me? 20 times 1 is 20. And 5t plus 4t is 9t. And t is equal to 29ths. Now that makes no sense. And as I tell all my classes, a mixed number is only used with units of measure. So what will that be? 29ths, will that be 3 and 2/9? 3 and 2/9 hours. Now if you wanted to convert 2/9 into hours, then you just multiply by, or change 2/9 into how many over 60. And that will give you an answer. Question. Hope everybody has that. I think I'm in lecture class asking people if they got questions. Okay. Most of your work problems are going to be that way, or are going to be in that form. How about George can paint a neighbor's house paint a neighbor's house 3 times as fast as Ricky. I don't know how to spell Ricky, so I'll just put a Y. One year, Ricky and George worked together. It took them 6 days to paint a house. How long would it take each of them? Like if they was to paint the same house. Sorry. How long would it take each to paint the same house? And this is the second type work problem. The first one we just did. Now, first of all, we need to let, and we'll just use the variable x here. George paints 3 times as fast as Ricky. Let's make that x. And of course, 3 times as fast would be 3x. This will be George. Okay. Now, so Ricky would be 3x. Yeah. Ricky would be 3x. Okay. Now, it takes 6 days to paint the house. So, let's figure out what that's going to be. That would be 6 over x for George, which is 1/6 x, or 6 times 1 over x. And that'd be 6/3 x, which could be 2x, but we're going to write it 6 over 3x. And that's going to be equal to 1. So we'll just add those two together, and that's equal to 1. multiply through by the common denominator, which is going to be 3x. And I'll take that to the next page. Try to leave it up here where you can see it. Let me just move this down. There we go. 6 over x, 6 over 3x equals 1. Okay. Take our common denominator of 3x. We did one like this. 3x and 6.6. 1. 3x over 1. 3x over 1. And the x cancels. 3 times 6 is 18. Plus the 3x cancels. That leaves 6. And this is equal to 3x. And 18 plus 6 is 24. Divide by 3. Takes George 8 hours, and takes Ricky, dang old, 24 hours. Paint the same house. So there's another example of a work problem. Either you're going to find out how long it takes both of them or how long it takes each of them. That's the two types of work problems. And the motion problems are in the second part of 6.7. The speed of the stream is 2 miles per hour. I can't. There we go. MPH. A boat travels 13 miles upstream. In the same amount of time it takes to travel 17 miles downstream. Okay? What is the speed of the boat in still water? And one of the good reasons I use still water is that you're going to set the equation equal to each other. Alright, so upstream, I'm going to say this is upstream, and this is downstream. Now, the distance traveled upstream is 13 miles. This is the same amount of time. T is equal to 0, T is equal to whatever. Okay, the same amount of time. So let's say 30 minutes. He went 30 minutes this way, he traveled 13 miles. He went 30 minutes this way, he traveled 17 miles. Of course, why? Because the stream is helping on this one. The speed of the stream, let's just draw the stream right here. The stream is going this way. Okay? So if you're paddling a boat and you're going upstream, you're going to be working a little bit harder. Okay? So that's why it's 13 miles. I'm just using the 30 minutes. I'm just using that for, just to get your mind thinking. The time is 30 minutes for both of them. Now, it doesn't mention anything about time. I'm just using that for an example. So, would it be safe to say that the stream is pushing against you right here and helping you right here. So upstream is going to be a minus and downstream is going to be a plus. So that would be x minus 2 and x plus 2. And then the time we don't know. What is time? Well, remember, distance equals rate times time. Therefore, time is equal to distance over r. Hey, we got distance and we got r. So time is equal to 13 miles over x minus 2. And we're going to set it equal to 17 miles over x plus 2 because of still water. Multiply through by the common denominator. I'm going to skip a step here, put the baby step in. So x plus 2, x minus 2 over 1, x plus 2, x minus 2 over 1. 13 over x minus 2 is equal to 17 over x plus 2. And that will give us, hold on just a second. We're going to cross that out, and that will give us, I'm sorry about that phone call. That will give us x plus 2 times 13 and equal to 17 times x minus 2. So let's cancel that x minus 2 out and cancel this x plus 2 out. And yes, you can cross multiply, that's fine. You get 13 times x plus 2 is equal to 13 times x minus 2. I'm sorry, 17 times x minus 2. 13x plus 26 is equal to 17x minus 34. And that'll give you minus 13x minus 13x. 26 is equal to 4x minus 34 plus 34 plus 34. And that'll give you 4x is equal to 60 divided by 4. And that comes out to be, I have no idea. 4 will go into 60 one time. It'll be 15. X is equal to 15. So it took 15 minutes for them to travel downstream and upstream. Sorry about that. 15 minutes. Because 4 will go into 60. Hope that helps.